Hello everyone, my name is Roger. Today I'm very happy to work with LeetCode, and I will going to share two things. First, I'm going to share some tips for software engineer coding interview. And second, I'm going to go through a mock interview using LeetCode online interview platform and apply these tips in action. So I think the most challenging part for a software engineer interview is the whiteboard coding part. Or in some cases, you are required to write code on an online editor. So given that, I'm going to share with you about 5 steps how to handle a coding interview properly. Just before we start to talk about 5 steps, I just want to make sure that everybody understand coding interview or whiteboard interview is not a school exercise where a teacher give you an assignment and you just finish it. So it's an interactive process that you need to communicate with your interviewer to mimic the real working experience. So some people may ask why I pass through 1,000 LeetCode coding questions, but I still fail in a coding interview. Today, I'm going to share the tips to give you a framework that you can follow to completely answer a coding interview question. Okay, let's get started. And the first step is you need to clarify your question. No matter if your question is simple enough, like a reverse linked list, or it is super long as a paragraph that make up by some Google engineers, you need to ask a question about the problem itself, and also be sure to go through the edge case you can think of with your interviewer. The second step is to describe your algorithm. So the way you describe is from the easiest brute force way to the more advanced algorithm. So don't be afraid that you think the brute force is too obvious. Just put it out there and optimize along the way. So the way you describe your algorithm can through some pseudocode or draw some block diagram on the whiteboard. The purpose is to let the interviewer understand what direction you are going towards. And also, if you are too far away from the so-called correct answer, the interviewer may give you some hint along the way. The third step is really to start writing the code. In terms of writing the code, you need to be aware of 3 points. One is to be professional while you're writing the code, in terms of like naming convention, the coding style, how to name a function, so on and so forth. So don't do things like int A or int B. Just do naming as if you are really in a working environment. The second part of the coding is you need to be aware to check the edge case. Whenever you write a function, you initially check the edge case first and be sure your program will not crash. And the third part is to use sub-function if it is possible. Let's move on to step 4. At this point, you already have your algorithm developed and you are ready to go. So here, instead of tell the interviewer, okay, I've finished the problem, you just walk through a test case yourself. So the purpose of this is to give yourself some confidence and find a bug if there is any. So the way to go through a test case might be, if you are doing whiteboard coding, then just come up with a test case and walk through the coding you just did step by step and write out the state clearly on the side of the whiteboard. If it's an online editor, you may just write a test case and the main function and just run your code. Both ways will just work. But in any case, don't forget to do a test case. The fifth step and the final step is to analyze your code complexity. It includes both the time complexity and the space complexity. Remember, this step is possibly optional during a code interview. So if you are pretty sure your answer will be correct, then just spell it out so that you can give the interviewer an impression that you understand your code pretty deeply. And if you are not sure about your complexity, for example, you are writing some dynamic programming or some recursion, then in that case, you may choose not to offer the answer. But if the interviewer just asks you, then you probably just provide your educated guess over there. Okay, now we go through the 5 steps that help you to go through a coding interview, which are ask questions about the problem, and describe your algorithm, and be aware when you're writing the code, and also run a test case after you finish, and eventually optionally describe your coding complexity. Okay, now let's put it into action and go through a mock interview using LeetCode online interview platform and see how these techniques are used in reality.
Hi everyone, I'm Emma. I will be the interviewer in the mock interview.
Hi, I'm Roger. I'm going to be the candidate, Lei Li in this case.
First of all, I'm at the LeetCode homepage. You can see on the bar here, there is an interview to start an interview, or you can just on the right, as it is the new feature of the LeetCode. So I'll start here. I'll start an online interview. Here we go, and I authorize. I am putting my name in it. And then on the upper left, I'm going to create an interview. Cool. Interview's name, mock interview for today. Cool. I click create, and then I can click into it. Now I'm joining the interview. So here it's just a regular whiteboard interview, and I'm going to create another question, which I'm going to select a question from the LeetCode directly. I'm going to select, oops. Right, I'm going to select an easy, reverse a linked list. Cool. And so so this is the first question that I'm going to ask the candidate. And I'm also planning to have my own question. So then I'm going to use the whiteboard feature. I'm going to copy and paste my own question, the body of my question. Cool. I'm going to comment it out. So now I've prepared 2 questions on the whiteboard. Now I'm going to invite my candidate. I'm going to copy the interview link and send it to the candidate. So here is the resume of my candidate. His name is Li Lei. And he's a software engineer with a product driven. Cool. I've had a rough idea of what. Awesome. So I'm going to start the call with a video chat.
Okay, I see the interviewer is starting a video call. Okay, I'm going to join there.
It's pretty smooth. Hi, Li Lei. I'm Emma.
Hey, Emma. How are you?
Good. Thank you for asking, and thank you for taking the time and interview with us.
Sure.
How was your day?
Yeah, it's doing good.
Okay, great. Let's get started. I have your resume here, and I'm very impressed with your experience.
Okay.
Cool. First of all, tell me a little bit about yourself.
Sure. My name is Lei. I'm currently a software engineer at XXX company. So I'm mostly a mobile developer, and I have good experience on CI integration before at my current job.
Oh, I see. Yeah, at the ABC app, right?
Yes.
Cool. Tell me a little bit more about the CI pipeline that you've developed.
Sure. The goal of this project is essentially to increase our continuous delivery success rate and minimize the regression. So I did some research between XXX framework and YYY framework, and eventually decided to use XX framework. So my role is essentially to implement this pipeline, and every submission will be automatically run through a bunch of tests. So that is how it is implemented at this point.
Awesome. Cool. So were there any technical difficulties or challenges that you've experienced?
Yes. So essentially our need is to have parallelism around these continuous integration framework. So essentially we have multiple engineers may submit the diff at the same time. So we need to run instances in parallel. So given that, XXX framework actually did a good job compared to YYY framework. So it has achieved 25% of performance improvement based on our test. So that's why I'm using this framework.
Oh, thank you. That's awesome. Your manager must be very happy about it.
Yeah.
Cool. Before we get into coding, I have some very basic computer science questions for you.
Okay.
First of all, since you mentioned that you are a mobile software engineer, especially on iOS, so tell me a little bit about iOS memory management.
Sure. iOS memory management is using something called reference counting. So whenever you create an object or you assign an object, the reference count will +1. If it goes out of the scope, the reference count will go -1. When it reaches 0, so essentially the underlying framework will start to the operating system will release this memory.
You've also listed here Java. You also know it as well. So
a little bit.
Can you tell me a little bit? What's the difference between the memory management between Java and iOS?
Oh, actually for Java, because I just use it for some small projects, so I'm not specifically sure how it is done. I know it's garbage collection, but I don't know the difference between, for example, iOS and Java.
Okay, cool. Totally makes sense. Cool, since you were more specialized on the iOS side. Cool, awesome. So a little bit another question. Do you know polymorphism, or what's how the underneath the underneath technology?
Yeah. So for polymorphism is essentially for object-oriented programming, like C++. In that case, you can have a base pointer, and using that base pointer, if it is pointing to a derived object, then it will have the derived class behavior instead of the base class behavior. So in my understanding, it is done using function pointer. So essentially, when you define a virtual function, it has a virtual table, which is essentially a table of function pointers. So given that, because you assign a new function pointer to with the derived class, so it will look up the table and call the right function accordingly, so that it has different behavior compared to the base class.
Okay, cool. Let's get into coding.
Okay.
So we have 2 questions today.
Okay.
I'm going to start this question for you. So can you see it?
Yes, I saw interviewer has switched to the next question, so it's showing the problem.
Okay, cool. So it's given the head of a singly linked list, reverse the linked list. Okay,
so for this question, I just want to confirm that it is a singular linked list. It's not a double one. Okay.
You're right.
And also, what if the head is null? In that case, do we throw error or?
Yeah, you can just return me a null.
Okay. In that case, just return a null. So for this one, I was thinking maybe we can use recursion, because like reverse the whole list is essentially reverse the letter part and then reverse the first node. So that's one way. And more intuitively, I'm thinking is essentially go through each node. So it only needs to know what is the next, what is the previous, and change the next pointer of the current node to the previous node, and you just move forward. So if you update one by one, when you reach the end of the linked list, you are done, and you just return the last node or the first node of the new linked list. So that's what I'm thinking.
See.
Yeah.
So
and in
pointers,
yeah. So just using state and pointers. And since I code mostly in C++, so you can essentially use pointer of pointer as well in this case. But I will probably just stick with the easy way. So essentially, if you have 1 and 2, so if you are looking at current node of 2, then your previous node is 1, and your next node is null. So given this state, essentially you just want to change your current node next into previous. So essentially you have 2.21, and if you update the previous state and also the next state, then your current state will become null, because null is the next state, and your previous case will become 2, and so it kind of complete the state over there.
Okay, cool. You mentioned there were 3 methods that you can think of.
Mm-hmm.
Can you tell me a little bit, your thoughts behind why you are picking this one instead
Yeah,
of
sure.
the other 2?
Yeah, for this, it's I think it's the most straightforward one. Essentially,
Okay.
you just process one by one and move to the other state. So I think it's easier to understand in terms of the code.
Okay, cool. You can get started. Can I switch it for you?
Oh,
Okay.
that's weird. Okay, so yeah. So given that, as we talked about, if the input, like the head node, is equals to null, then in that case, I just handled edge case, which return head, which essentially return null.
Okay.
And as I described, we need to define 2 state. One is the previous node, starting as null pointer.
Okay.
And the other one is the next node, which also start with the null pointer. So now it goes to state by state process. So we have a while loop. If head is not equals to null pointer, then we continue to process the state. So the way we process here, because we are going to switch the next pointer of the head, which is the node we are currently processing with. So I need to mark down what is the next node. So it is essentially head next. So I just pre-save the state. And now we are doing the reverse, which essentially is head next is previous. This is reverse. And now we need to move forward. So how to move forward is essentially head needs to move forward. Oh, actually previous need to move forward first. So previous is equals to head. And the second part is next need to, head need to move first, move forward as well. Okay. So the way head move forward is head equals to next. So given that, we can go back to the while loop, and all these head, previous and next is updated. Okay. So at the end of that, we just return head. Okay, so I think in my work, let's just go through a test case. So essentially, suppose we have 1 convert to 2. So your previous node is null. Your current node is head, which is 1. And your next node is 2. So when we enter the while loop, so next equals to head next. So next is 2, which is correct. And head next is previous. So in that case, you have 1 pointing to null, because previous is null in this case, right? And you have 2 here, and 2 is pointing to null. Okay, so now we reverse the linked list, and you updated previous and head state. So previous is equals to head, which previous become 1, and head is equal to next, which actually this one is head. So, and head becomes 2, right? So now you go to the loop again, because head is not null pointer yet. So we go to the next loop. Here we update next equal to head next. So meaning this one becomes null. And head next is previous. So essentially head is 2. Head next is previous. So 2 pointing to 1 now. You break the link here. And we update the state. Previous is equals to head. Previous become 2. And head equals to next. Head becomes to null pointer as well. Okay, now we go to the while loop, because head is equals to null pointer, so we didn't enter the while loop. Now we return head. I found a bug here. So essentially I cannot return the head because head is null here. Instead, I should return the last node, which is previous. So, okay, we found a bug from this unit test. Yeah, with LeetCode, I can run this test case as well. Let's put a... Okay, cool. Looks like it gets correct.
Okay, awesome.
Yeah.
Thanks, Lile. Since you've finished, we can actually evaluate your code. So I'll hit evaluate here. It has been accepted. Cool. Let's move on to the next question.
Sure.
I'm going to switch. Can you see the next question?
Yes.
Okay, so the question is in the comment section. I'll give you a couple minutes to read, and please let me know if you have any questions.
Okay, yeah, looks like we need to print a list. So I just want to make sure we can only use these two APIs to access the content.
Correct. You don't have any other.
Okay, and I cannot change the data because it's opaque, right?
No,
okay.
You can't. You can't assume anything underneath.
Okay, sounds good. So now I'm describing my algorithm. So I'm thinking because I want to print reversely. So one thing is to use a stack. The other one is just using recursion. The idea is because, for example, if you have a list like 1, 2, 3, and you want to print it reversely. So from a recursion perspective, your sub-problem is to print 2, 3. And at 2, 3, your sub-problem is to print 3. So when you reach here, if you don't have the next node, you can print 3 directly.
Okay.
And you go back to the next previous state, you print 2, which means when you solve the sub-problem, you print your current value. And same apply to the top level. So here you already printed 3, 2, and you just print 1 out. So I think that will probably work.
Okay. You also mentioned you want to do stack. And can you tell me a little bit why you decided to choose this one over the other?
I just feel the recursion is kind of intuitive in this case. And for stack, you need to put this in and print out. Essentially, it's the same thing, but I just feel like it's better to use recursion. And also, you print value. You need to call this print value function here. So essentially, you don't know how it will print. Maybe it has a prefix of the string or something like that. So I just feel better just to call using the recursion so that you don't need to get a value. You can just use print value to print.
Okay. So there weren't any get value. So if you use stack,
you need to get value, but you don't know, next. Right?
You can put node in the stack.
Oh, yeah, I can put nodes in the stack and get value as well. Yeah, that's true. Yeah.
Okay, cool. Anyways, I just wanted to know your thoughts between.
Yeah. Cool. So I will just use recursion. So my function. Oh, by the way, if the linked list is null, then I just return without printing anything.
Can you please throw me an error?
What if the input is null? Shall I return anything or just go?
Just do nothing.
Okay, do nothing. Sure, sounds good. So I will define print reverse. So it takes a list node pointer head. Okay, so with that, if check the edge case always, if head is null. Then just return.
Okay.
If not the case, I'm going to recursively run it. So print reverse. And since head is not null, so we can safely call head and get next.
Okay.
So given that, it is solving the sub-problem for me. So I would assume it printed the sub-problem already.
Okay.
And at this level, I just need to do head print value. Okay. Okay, I just do head print value in this case.
Okay.
So with that, let's run a simple test case. Suppose you have 1, 2, 3. And when you enter, your head is equals to 1. So now you print to reverse head get next, which is 2. So essentially you print 2, 3 in this loop, but you actually enter the next level. And here your head is 2. So head is not null. So you print, you recursively calling head get next, which is 3. So in this case, you enter here. And it's similar. So here, because your head is 3, not null, so you enter it one last time, and you actually get head next, which is null. So here you're at null. So when you're at null, you actually go here and just return without doing anything, so you just exit. So when you return to the next level, so you have head print value, so you print out 3 first, and you enter, exit. Now you come back here, so you print head print value, which is 2, so you print 2 here. When you return to the outer level, your head is actually currently 1, and you call head print value, so you print 1 eventually, and you complete all the stack. So you print out 3 to 1.
To your previous question, what if I want to, if the head is null, you need to throw me an error?
Okay, so in that case, you cannot use this as an end condition. So actually, I prefer to separate out.
Okay.
So when you enter this function, you can still have all these, like call it print reverse internal, which just do the recursion part. And for example, if you check, this is the outside function.
Okay.
So let's just do this.
Yeah.
So do here. You have the void, and you have. Okay, so you now have this. So given that if so we check at the outer function. So if head is equals to null, then you just handle error here and return. Basically, you do a throw. And otherwise, you just call internal function, because now you know the head will not be null, so it just become the previous problem. So you only use head equal to null as the exit condition. So
okay, cool. Can you explain what's the time and space complexity of this problem?
Sure. So for time, I need to loop through the list, and also because it's recursion, so it actually add every level into the stack.
Okay.
So essentially, it is O(n) for both time complexity and space complexity.
Okay. What if I'm asking you that you can't use any extra space?
Okay. If I cannot use any extra space, stack is also extra space, and stack. Do you have any hint for this? I currently don't have idea on that.
I see. So now you just loop through the array once, right? So if I don't give you any extra space, you can sacrifice time for it.
Okay, so if time is not a limit, time complexity is not a limit, maybe we can loop through the linked list multiple times. So essentially, for the first time, I just go to the last node, and also I know what is the length of the linked list. So for example, for the first time, I just go to the last node, and I know count is 3. So I just print out this one, and next time I start from the very beginning and find out the second node essentially, and print it out. And next time I just go with the first node and print it out. So essentially, the time-wise, I need to go n multiplied by n minus 1, so divided by 2. So it's essentially a n squared complexity for time and O(n) for space, because I don't need extra memory for every state.
I see. Thank you, Li for your time. Nice to meet you.
Okay, sounds good. Thanks. Bye.
Bye.
Okay, we just finished our mock interview. I clarify if it is a singular linked list or double linked list, and also how to handle the edge case, which is empty node. The second part is to describe my algorithm. So I use some comments to kind of letting the interviewer to understand my thinking process. And when I write the code, I first start with the edge case check and also be aware of the naming, including the variable naming, so on and so forth, as we just talked. And in this step, we need to be aware that after you finish the code, you don't immediately say, okay, I'm done. I went through my code by using a simple test case and find out the return value was wrong in the first place. In that case, if I correct by myself, then it's actually a bonus point in my interview. And as last step, I optionally analyze my algorithm's time complexity and space complexity. Just be aware, like during the whole process, it's a communicative process. So it's not like you're getting a programming question and you just write a code by yourself. So by asking questions, by describing your thinking process, the interviewer can understand your approach easier. Even during the process, I can ask for hints. For example, I don't know how to optimize for space. I just ask directly if there is any hint and what I'm currently thinking. And also during the interview, it is okay to ask for hint. For example, I'm not sure how to optimize the space complexity, so I just ask for that, telling the interviewer what I'm thinking or what might be, and ask for what might be a possible way for me to continue on that problem.